right, so we are at 11:30. We have people coming in the room, but we'll get started. For the interest of time, welcome. This is the RAT session. I think people are probably still trying to find this room. So let's see. Ned, would you mind advancing the slide? Again, this is the Notewell. You should already be familiar with it. It applies for all your contributions on lists and GitHub and in the room. All right, next slide. And the code of conduct, we went over this yesterday, and be respectful to your peers in all your interactions. As I mentioned yesterday, this could even help get your comments integrated into drafts quicker, right? When you give nice, polite responses back and forth, people will be able to respond in kind. And it really does speed everything up because we are here for the good of the internet. And be prepared to participate. And so I am hoping we get a flurry of just reviews. We'll begin last call on some of the documents that are ready, but we're going to do them in stages. Right now, we're still looking for reviews on documents that we think might be ready, but we need to have a solid set of reviews on them before we can progress them to last call so that we know that they've gotten the review, they've been edited enough, and that we think we're at a point of consensus, right? So once you're at that point, then you put into working group last call, hoping for minimal things caught at that point in time. Okay, next slide, please. Do we have two note takers? I didn't see anyone else respond yesterday. I know we have one.
Osama,
right?
We have Osama, yeah, but still looking for another.
Can someone? Oh, great. Yep, so now we have two. Thank you both. And one chat watcher. I will watch it as well, but you can watch
volunteer?
It. All right, that's a lot of multitasking. Thank you, Osama. If someone else wants to volunteer, it is a way to contribute.
Who volunteered to take notes?
Jean, is that how we say your name? Yeah, he picked his head up, so that's got to be right then. Jean. Ned was asking who volunteered for notes. Yes.
Sang Jun?
Yes. Thank you. Great. And JP has volunteered to watch the chat. Much appreciated. Next slide, please. I think, or do we jump into the presentation? So here are the materials, and if you need assistance, hopefully at this point in the week, we're all set. And here's our agenda. Is there any agenda bashing? Okay, so the first draft up is CoServe, Paul Howard.
Yes, hello. Is my audio coming through?
Yes, it is. Good morning, or...
Yes, indeed. Thank you, Ned. Okay, so thanks, Chairs. Hello, everyone. Sorry I can't be there in person. So I'm Paul. I'm co-editor of the CoServe draft. This is a CoServe progress update. So I'm going to talk about the work that has been going on in the draft since our last meeting in Madrid, and also provide some updates around running code. I think I have a 10+5 slot. So can I politely request that we just do brief or clarifying questions only, just while I get through the material during that 10 minutes, just so I don't run out of time. And then I hope that we can have any more involved conversations at the end. Okay, can we do the next slide, please, Ned?
I passed the clicker to you. Do you see it? Progress to your slide.
I don't know.
Okay.
What do I need to do? Okay, so first a quick recap. Since this is a relatively new entry to the working group, so CoServe stands for the Concise Selector for Endorsements and Reference Values.
Ned, you can pass it to him directly under his, where he's in the working group. If you see the same little document with a plus sign in there, you can hand him the control. Yeah, you did it. There you go.
Okay.
That's the way. That's the way.
I see numbers at the bottom now. Okay, thank you. I will try to use that. Thanks, Deb. So CoServe plays into the conveyance space between the endorser and the verifier, or between the reference value provider and the verifier. So CoServe builds itself on the foundations of what we already have, namely CBOR and CORIM, but also tries to address some gaps, specifically around conveyance. So CORIM describes endorsements and reference values, but it lacks a selector, it lacks a query language, and this is what CoServe adds. So it's a query language specifically for the RATS artifacts, namely trust anchors, reference values, and endorse values. So it's super targeted at this problem space. The query response language is defined independently of any transport, so you can transact it over HTTP REST or CoAP, and because it's a query response language, it can support transactional pull interaction models, but it has the potential to support continuous synchronization models as well. It borrows from CORIM very heavily and takes every opportunity to reuse common parts of the data model, in particular the triples. So we're also designing it to facilitate interactions across what I call real world or messy supply chains, complex supply chains where there could be multiple parties contributing endorsements into integrated systems that then need to be attested. So we could have levels of indirection. The diagram shown here is an illustrative example how that might look, but it is just an example. CoServe is not at all prescriptive about what supply chains or deployments need to look like. It does not require aggregation. It is not based on aggregation. It has nothing to say about which specific entities might choose to trust each other. It's just an interface draft. And the data model is sufficiently general purpose for deployments to make those trust decisions for themselves. So this is fundamentally what CoServe is, a common query language for vendors to harmonize on, based on CBOR and CORIM, supporting flexible interactions and transports, and supporting supply chain complexity. Right, let's see if I can take us to the next slide then. Okay, that seemed to work. So the main piece of news, of course, since Madrid is that CoServe is now an adopted draft of the working group. We deferred the adoption from Madrid and then did a 3-week call on the mailing list. And I do want to take this opportunity to say thank you to all the participants in the group for your energy and engagement during that process. Several people contributed to the conversation on the list. Many issues have been collected into GitHub as a result of that. So once again, many thanks. Okay, let me proceed. So I'll talk a little bit about how the draft has evolved and what the next steps are. So one of the great positives that came out of that 3-week adoption call is that we've welcomed 2 new co-authors or co-editors of the draft. So that's Giri and Ding. Thanks to both of you for joining in this effort and helping to pick up the pen, as it were, going forward. The other headline item is that we've addressed the biggest of the outstanding roadmap issues from last time. So we always intended that concrete API bindings would be a feature of the draft, starting with an HTTP API in order to promote interoperable ecosystem. So that has now been added. So version 2 of the adopted draft includes, there's a new top level section, section 6, which focuses on these concrete API bindings. The binding that has been defined is a transactional request response with HTTP GET for executing individual CoServe queries and returning the results. So the way this is done is we make the query part of the URL path so that the query effectively becomes a canonical identifier for the selected artifacts. The draft requires that the queries be encoded deterministically in CBOR for precisely this reason, right? It also means that standard HTTP caching behavior can be used both server-side and client-side. Alongside that, the transactional API, we also have a service discovery protocol using well-known URLs as per RFC 8615. Discovery document details the available API endpoints and supported media types, among some other properties that are aimed at bootstrapping successful interactions between the clients and the server. So the discovery document is obtained from the well-known URL. There's a normative CDDL data model for that document, and it can be conveyed either as CBOR or as JSON, depending upon the client's preference. Okay, turning to future work for the time being, this is somewhat less feature-oriented now. The focus is now much more on shoring up what is already there, and of course addressing the feedback and reviews from the group participants. So looking at the supply chain threat model, or the trust model, is going to be a big part of this. Again, the feedback so far has been clear that the draft doesn't say enough, right? We need a clearer definition of trust links between these supply chain producers and consumers. We need to do a better job of security considerations and privacy considerations, of course, especially with regards to the aggregation concept. And more generally, there's a wealth of review feedback that's all captured in GitHub issues, and I'll be working through these with the co-editors. And there is implementation work, proof of concept work going on, which I'll talk about in just a second. And of course, part of the purpose of any such POC is to flush out spec issues and inconsistencies. So we'll also prioritize addressing those as and when we discover them. So that's what the next steps are looking like to me at the moment. So quickly onto our running code updates. So this is all based in the Verizon project so far. And the situation is moving so fast here that this slide is actually already out of date, because the proof of concept implementation for server-side CoServe in Verizon is now mainline as of just this week. So it's no longer in just a feature branch. Fantastic news, and enormous thanks as ever to Thomas for some Herculean efforts there, and also to my colleagues Yogesh and Sergey in the Verizon community for their reviews and input. And it means that Verizon as a service can now be deployed as an endorsement distributor as well as a verifier. So it can act in the endorser and reference value provider roles. It exemplifies CoServe by implementing the API as defined in the draft. So it has these new get methods that I talked about. There's a method to get the discovery details from the well-known URL, and there's a method to execute a transactional query. And like most things in Verizon, the actual implementation is scheme specific and delegated to plugins. So the store plugins transform CoServe queries into native store queries, and correspondingly transform the native query results into CoServe results. And we also have this experimental proof of concept for proxy plugins, which were preserved from the coding efforts of the previous IETF hackathon in Madrid. So these show CoServe as a proxy layer, but they get their data not from Verizon's internal stores, but from external cloud services. So we've demonstrated proxying that across to the NVIDIA RIM service and also the AMD KDS. In terms of common library support for CoServe, moving down the diagram, so these are the libraries that you can use on both the server side and the client side. We have a strong story on the Golang side, where the CoServe data model is fully implemented in mainline. There's a fairly new equivalent effort going on in the Rust side as well. So there's a new CoServe RS repository in Verizon, which currently only provides the discovery document data types, but that's going to evolve soon to implement the full CoServe query data model as well. And then this work is going to feed into a full client-side story in Rust, which is still a work in progress, where we'll use the Rust CCA token tool to exemplify a verifier that uses CoServe to retrieve endorsements from a service. And you can see here that we're gradually building out an end-to-end story across the server and the client. And I think that is my update, because slide 6 is just a resources slide, which I don't feel the need to talk about. So happy to open up for discussions. Looks like Usama's at the front of the queue. Go ahead, Usama.
Sama to you, Dresden. Yeah. If you go back a couple of slides, the one with the client and the server.
The running code slide, this one.
Yeah, this one.
Mhm.
I'm still. Could you say a little bit more about where is the aggregator in this specific one? So the way I view it is from my perspective. Let's say, kind of just resketching it. My mind, I have as we have in the TLS client on the left, server on the right. I'm seeing that you have something in between, which is CoServe. And in my mind, I'm trying to map it over to a protocol kind of a thing. And I'm not seeing where does the aggregator lie in all of this. So could you clarify a little bit more about where is the aggregator?
Well, to start with, I'd reiterate what I said at the beginning, right, which is aggregator is not sort of fundamental to CoServe at all, right?
Sure,
it's a model that's supported. It's not a model that's necessary.
I completely understand that.
Here, in what we have in Verizon so far, I think you would say that the aggregation is more of a pass-through model. So when we have these proxy plugins, and the proxy plugins are purely experimental, right? The reason they are there is because we wanted to demonstrate that it was feasible to have some kind of common query language and common API, right, to those things. So basically, it's not so much aggregation, but more indirection, I guess.
So just to recap the answer, in my words, you are saying there is no aggregator here. Is it correct?
Well, I guess so. There is a collection going on, right? Because if Verizon is querying store plugins, and those store plugins, there may have been multiple sources that provisioned endorsements into that internal database that Verizon has visibility of. So there is a sort of there could be an implicit aggregation going on there. Once again, aggregation is largely an implementation detail. It's not as architectural. It's not as fundamental to the design as you may think.
Okay, let me rephrase my question. Could we? So at least you agree that that's an implementation issue, and in the RFCs typically we don't write implementation issues. That's left over to the implementers. Could we just get rid of the aggregator completely from the draft? Is it acceptable to the authors?
No.
Let the implementers decide. If they want to do, then do it. If they don't want to do it, then don't do them. So could we get rid of the aggregator completely from the draft?
Well, no, because if you want to offer that choice, then you need the data model needs to be rich enough to offer the choice. If we don't have that in the data model, then there is no choice that we're offering to implementers.
So then my concern remains. So where is the aggregator? What is it doing? Where is it? And how do I perceive it in my view, in my mind, that the perspective that was presented to me that it's an endorser, I completely reject that. From the perspective, if you see from the endorser side, it's basically not an endorser at all. It's something in between. And that is, I'm just wrapping my head around this and I can't figure out what it is. So I would like to see one figure which kind of shows me where that aggregator is, so that I can kind of get a feeling of what it is doing and what are the security considerations around that. Does that make sense?
We only have 30 seconds left.
Yeah, we're running out of time. I mean, this is a running code update slide, right? It's not really designed to be an architectural slide as such. It's just a news flash. Thomas, are we out of time?
Sorry.
No,
Yeah,
we can take Thomas's question. Just make it quick. Thank you.
It wasn't a question. It was an answer to Sama's. We certainly don't want to drop the aggregator from the draft because we want to A, offer it to consumers, and B, analyze, with implications. So we don't want to hide anything.
Okay, thank you. We'll take additional discussion to the list or in open mic time later, and let's move on to the next draft. Thanks, Paul.
Sure, no worries. Thank you.
Uh,
Is MCR in the room?
Michael Richardson's not back in the room if he was supposed to present this, so maybe we switch ahead.
Okay.
Okay, next presenter. Is this Yogesh or Hank?
Or Mark?
Oh, or Mark. Sorry.
Okay.
Thank you, Mark.
Yeah. Should I share my screen or go with that one? It's up to you.
I handed you the clicker. Can you
Okay.
run the slides?
Yeah. Okay, that's fine. Just give me a second here. I'm gonna rearrange my screens here, too many screens. All right. So, hello everyone. I am Mark Novak. I'm presenting on behalf of the Trustworthy Workload Identity Special Interest Group at the Confidential Computing Consortium, and this is a joint submission with Yogesh and Hank. And I'm required to, by my employer, JP Morgan Chase, to say that these are my own opinions. Okay, so let's talk about trustworthy workload identity and RATs. So the first thing I want to mention is I actually believe this is one of the most important talks in RATs at this IETF, in my personal opinion, because it has to do with money. This is the talk about how to grow the total addressable market of confidential computing, how to make it deployable. And the work on trustworthy workload identity started in part because my employer tried to see how we can harmonize workload identity at the firm. And then I started asking a question, can I also do this for confidential workloads in alignment with regular legacy, non-confidential workloads? And that resulted in a set of realizations that led to what I'm presenting here. So I'm going to start with maybe a set of platitudes, but just to frame what I'm talking about. So we care about data protection, what we call the whole of enterprise concern. So we talk about at rest, in transit, in use, and then there is this realization that most, certainly cloud applications, are not just one database or virtual machine or one workload. It's a complex web of interactions where most data exchanges happen between pairs of workloads. In fact, very little data is exchanged between humans and machines. By a vast margin, data is exchanged between machines. So when you issue credentials to workloads, you're not going to be able to uplift your entire enterprise. We have something like 7,000 applications. And there is going to be a transition period where some workloads are run confidentially, others are run non-confidentially. But in the end, you need to issue same type of credential to all your workloads as you go through this transition. And turns out that any solution that you deploy, and again, this is very, very critical, you need to be manageable, you need to be deployable, and you need to do it at scale. On-premises, in the cloud, eventually on users' devices. And this talk is really about how to make confidential computing and computational computing specifically in connection with RATs manageable and deployable. So, okay, so that's the framing. Now let's talk about this, relying party empathy. So really what happens is you're relying parties, and relying parties is essentially something that authorizes requests, authenticates and authorizes requests, which I already explained. Most of them are coming from workloads, not from humans. These authorization policies need to remain stable for a really extended period of time, right? So we're talking about years or decades, and it needs to be done as software and hardware gets upgraded, as unsuccessful updates get rolled back. And there is something else. You have different management structures. You have people who own workloads and deploy applications, deploy applications, and there are people who manage hardware, and they're not the same people. And yet both hardware and software must remain within policy for the for the authorization policy to function. So normally what your relying party authorization policy will state will be, this is, I expect my client to be a payroll application, clear for highly classified information, or clear for PII, or maybe something about its physical location. So a bunch of stuff that is about related to the hardware and software of the client, maybe running on approved hardware, right? And a workload is usually in the middle of data processing. So it takes requests from a set of workloads and it makes requests to a set of other workloads. So it's both the client of interactions and it's a relying party of interactions. And in case of mutual authentication, it's really both, right? So now let's take a look at what RATS is offering today. This is where I say RATS lacks relying party empathy, and I'm quoting something from both the RATS charter on the left and the new AR4SI draft on the right. But you will see that things like, chip hardware or target developer or chip vendor, system component integrity composition, right? Ultimately, if my payroll database wants to have an authorization policy saying you're running on approved hardware or you're located in Germany, it really cannot frame its authorization policy in terms of, well, running on Intel or has this firmware version. I mean, all of that, of course, needs to be taken into consideration. But by the time this information is presented to the relying party, it needs to be converted 100% into relying party friendly, so business centric terms, not what I call propeller head terms. And the rest of the talk is about imbuing RATS with what I call relying party empathy. So first of all, let's note a possible point of confusion. When I say relying party here, it's ultimately the recipient of the workload credential. Which is not the same thing as or not necessarily the same thing as the RATS notion of relying party. In RATS, the relying party is whatever receives attestation results. And if the attestation results are fragile, so composed of things like firmware versions and boot counts and who the hardware manufacturer is, that is going to break your relying party, make your deployment unmanageable, so non-deployable. So, so now I'm going to start going more technical from sort of more business centric. So there will be two parts to what is being proposed here. First, there's going to be a new architectural building block, not necessarily a new service, but a new architectural building block. We'll talk about how it integrates into various places. It's called the claims mapper. That's a draft name, but we'll rename it something else. But the claims mapper receives as inputs, depending on the scenario, either the evidence or the attestation results about a workload. And what it outputs is a workload identity, some kind of identifier, maybe some additional claims. And these claims are stable. Stable means they survive upgrades, downgrades, switch from one type of hardware to another type of hardware, switch from container to VM, whatever that is. Because again, these are business-centric claims that come out of the claims mapper. And I will talk about how the claims mapper integrates with the workload credential issuance flows. So we'll talk about, depending on what it is, how you skin this cat, you're going to get your, different invocations of the claims mapper. Now, I will answer all questions. We'll have, I've requested 30 minutes for this talk for a reason. But let me go through the material and then we'll have a discussion. So, take your notes now. And I will be very happy to discuss everything here. Okay. So there are two parts to trustworthy workload identity in the context of RATS. One is that there is a credential key. So that's an asymmetric signing key. It's a secret. It only the idea is only authorized workloads can obtain that credential key. It can be self-generated. Or it can be received from some kind of a key store. So in some scenarios, every workload instance starts up, generates a key, and then somehow obtains a credential around it. In other cases, usually horizontal scale out, you will be given a key, but you have to retrieve a key securely from some kind of a key store, right? So that's the first part. You need a credential key. And then you need a credential itself. So the credential could be X509, it could be the WIMSI workload identity token, ultimately maybe something else, but it's a public piece of information. It contains the public portion of credential key. It's always generated and signed by some credential authority, and without the proof of possession, so without access to the credential key, you can't use it. So you can put it in a public place, you can't use it without something that basically requires attestation to obtain. So those are the two parts. And the solution basically pivots on where the key comes from and where the credential comes from. So we will be going over a number of different interaction diagrams that preserve rats, right? So we're not changing the rats architecture, but we will talk about what happens depending on whether the credential key is generated inside the workload and certified by remote attestation, or it's retrieved by key store, contingent on remote attestation. So that's the key source. And the second pivot is the credential source, where the workload gets the credential. So it could get it directly from the verifier as part of attestation results. It would get it from the credential authority, or it could get it from the workload owner, so the control plane. So so getting your credentials and the keys from the workload owner is what happens for legacy workloads today. So like you put some credentials on the volume, your container starts, retrieves the credential and the key, and off to the races, right? So that would be that sort of thing. But we need to do it all securely, and we need to make it contingent on attestation. And here we come to a set of credential acquisition mechanisms that is dictated by this pivot matrix, which I show here. Now, again, in the columns, you have your credential source, which could be verifier, credential authority, workload owner. Credential source is not the credential origin. The credential origin is always the credential authority. But credential source is who the workload needs to contact to get the credential. And the key source is whether it's the workload generating its own key or it gets it from the key stores, some kind of an HSM. The naming is really confusing. I couldn't come up with anything better, but for now we'll just have to live with it. It's really a identifier of the topology. So I'll talk about the naming, but the one that's immediately following, WVCA, which means the workload talks to the verifier, which in turn talks to the CA, and so on and so forth. So now, I do not expect that we'll be able to do the detailed security analysis of each of the proposed flows. I just want to show that perhaps modulo some tweaks and fixing some security vulnerabilities and additional concerns, we ought to be able to get to where we need to be, both with unmodified verifiers as they exist today, and with updated verifiers that I hope will exist after this proposal is adopted eventually. So now the next 4 slides, I will be going over the various flows fairly quickly. Again, do not have an expectation that there is no security bug hiding inside any of them. That would require additional pairs of eyes. And after I cover all 4, I will give you some additional links to what you can read, and then we can have the discussion. So far, so good, right? All right. So the first one, this is the workload talking to a modified verifier. You cannot do this today. But hopefully you will be able to. So this is where you generate a credential key, you create a credential request using the proof of possession of the credential key, you create some evidence, right, to get your quote, and then you request your attestation using this evidence. So in the evidence, you use your quote and then your credential request. The verifier will appraise the evidence, invoke the claims mapper to map the evidence to claims about the workload, and then it will go to the credential authority and say, please create me a credential with this identifier, these additional claims. The credential authority creates and signs the credential, returns the credential to the verifier, and then the verifier packages the credential inside the attestation results and sends it back to the workload. So you cannot do this today because neither Azure or Google verifiers, I don't believe, contain the functionality. I might be wrong, but we're hoping that that will exist. So that's one potential flow. This flow is where the verifier, so the workload does not go to the verifier at all. It talks directly to the credential authority, and then the credential authority will be the intermediary between the workload and the verifier. You can probably do this by changing the credential authorities like CAs that exist today, but that will work with existing verifiers again without modifying them. And so there is a quick nonce exchange, then the same kind of thing happens. You create the credential key, you certify it, well, so you create a credential request around it, and then you send the credential request to the credential authority, which extracts the evidence from the credential request, has the verifier appraise the evidence and map it to attestation results, and the verifier returns attestation results in the format that exists today. So no changes to the verifier. But now the credential authority will take these attestation results, invoke the claims mapper to get additional, like basically business-centric claims about the workload, package it up in the credential, send it back to the workload for usage. So that's the second way of doing it. The third one, and this is workload talks to the verifier first, and then workload talks to the CA. So again, this is unmodified verifier, and this is the credential authority with perhaps some additional code. This one is nice because it's probably the easiest to implement, but your credential acquisition now is not a one round trip to one service. It's actually 2 round trips to 2 different services. So first you need to go talk to the verifier, get back attestation results. That's garden variety attestation. And then you need to take the attestation results and submit them with a credential request to the credential authority, which then will invoke the claims mapper, get the business-centric claims, create the credential, send it back to you. Okay, so that's the third mechanism. And the fourth and final one, this one is your cloud orchestrated horizontal scale out, where you have lots and lots of identical workloads that you can't scale to have each workload instance generate and certify its own key. It's just going to blow your verifier, your CA out of the water. So instead, what happens is the workload owner, so the control plane, first creates a key and put some release policy on it, and there is a credential request that is created inside the key store for that key. And then finally, the workload owner works with the credential authority to obtain the credential. This is credential for everyone. And then at the end of the flow on the left, which is the provisioning flow, the key store contains the key, and the workload owner makes the credential available to the workload. Again, mounts on some sort of volume. The workload picks it up, credential is public, so off to the races we go. And on the right, the workload now needs to obtain the credential key for that credential that it just obtained. And this is the credential acquisition phase, where it will go to the verifier. It will, the verifier will appraise the evidence, compute attestation results. These attestation results are then presented to the key store with some public encryption key, and the key store will appraise the attestation results against the key release policy. It basically says, if you come to me with a statement from the verifier that these are the attestation results for you, I will then give you back the secret key, and then the workload can proceed to use it. So, okay. So again, I kind of went at a really turbo speed because I expect that detailed analysis can take place on mailing lists and whatnot. But I wanted to give you a few security issues. So of course, we need to put, the verifier and the credential authority and the key store are all fully trusted here. They're effectively part of your TCP. You do need to use TLS between the pairs of these trusted entities to eliminate a whole bunch of threats. There are some things that we don't know how to do yet. So when you live migrate a workload from Germany to France, you will in fact preserve that I'm in France claim, and we, that can break security expectations, and that can be bad and really bad if you're a regulated institution. And we still need to look at things like relay, replay, redirect, like all the things that Osama rightly worries about in many cases. So Okay. And finally, a bunch of links. So we have a charter for our special interest group. We have definitions. We have requirements, of which there are a lot more than I'm covering here, because this is just RATS focused. We have an early draft of our reference architecture, which contains all the flows I just presented here. And you can, of course, read, there's a GitHub for our draft that you're welcome to submit your issues to. So at this point, I'm happy to take all your questions.
Yaron's on the queue.
Hi, Mark. Thank you for the presentation. This is very interesting, and I think it's the right requirements in many senses, but I do have some questions. First of all, I'm seeing it in the context of whimsy. Please correct me if I'm completely off base.
So we have three main engagements in trustworthy workload identity. One is whimsy. And the problem with whimsy is that whimsy has this agent and node attestation. This is something we're taking up with the whimsy working group, in that the whimsy reference architecture is fundamentally incompatible with confidential computing. So, and that's because they have agent and the code concept of node attestation, where the workload under confidential computing doesn't trust the node. Okay, we have a separate thing that we need to do, having to do with provenance. I'm simply not going to attach provenance here, but this has to do with the fact that if my workload is asking me to transfer $1 billion and not $10,000, I may need to start asking you additional questions about the workload. So this is more closer to the co-serve and all the other mechanisms. So let's not talk provenance here. And the third pivot is RATs. And the problem with RATs specifically that I'm hoping to address as part of this proposal is that attestation results are fragile and unsuitable for entire classes of deployments that I worry about, right? Because they create really fragile authorization policies.
Okay. So with this in mind, I'd like to point out that in whimsy, some of the auxiliary data is passed separately from the credential. Specifically, the transaction token is sort of on its own, maybe too much on its own, because there's no crypto binding of that token to the whimsy credential. But still, it's an architecture I think you need to consider, at least for some of the use cases.
Yes,
And
transaction tokens are very much near and dear to my heart, so thank you for bringing it up, and we'll add it to the set of requirements, I suppose, and considerations for our reference architecture.
again, my point is not transaction tokens. My point is the analogy where auxiliary data is passed not inside the credential, not wrapping the credential, but separately from or modularly from the credential.
Well, so we'll need to think about that, because again, one of the key requirements for the world in which I operate is you cannot always expect that your counterparty is going to be updated or upgraded. So if it expects an X509 certificate, then it should probably continue to do exactly what it's doing. You can't change a line of code on it. So if it expects it, you need to provide it. Conversely, so it works on both ends. And if the moment you start talking about providing additional things, out of band things, changing the protocol, certainly possible. But you also need to understand it's a barrier to deployment. Maybe there are like more people in the queue, so we should probably get to those as well.
Sure, thank you.
Yuri?
Thanks, Mark, for the presentation. I'm going to be a little bit blunt here, but I've spent the better part of the year trying to figure out how the whimsy architecture can be of any use in AMD's confidential compute products. By the way, disclaimer: I work for AMD here in Monday, and I can't, and I have not been able to figure it out. And I think the live migration case that you kind of mentioned near the end of your slides, it actually presents a perfect example where a persistent workload identifier provides doesn't really provide security value when a workload migrates from one machine to another, simply because the security characteristics of that machine may not be consistent between the sending and receiving parties.
Yeah.
So I'm just wondering why a separate workload identity needs to even be provisioned with respect to and use attestation in that bootstrapping, when certain solutions like AMD's SEV S&P, which is used for confidential compute, actually have a tested workload identity where the attestation itself can actually reflect the security state of the platform on which the workload is running. Yet the workload originator can still provide in AMD terminology, you call that an ID block that can actually persist from one machine to another.
Right. So these are all very reasonable concerns. Let me try and answer this way. There is no hard dependency in what I'm proposing on Whimsy. Whimsy is if Whimsy can work, would like to make Whimsy work. And the goal here is to start, because remember, this is a total addressable market discussion. If you can't make something work, it's not going to get done. And or it's going to be done at a much, much smaller scale than is otherwise possible. So, confidential computing should, in my mind, not remain a niche thing. So what needs to happen is there needs to be a pathway for existing workload identity solutions to move forward. Right. So whatever we standardize on, I do not know if we're going to standardize on SPIFFE or Spiral. It could be something else. But a lot of the workloads that get those identities, if we standardize on them, will not be confidential for some time, but hopefully gradually so. And Whimsy or not, we need to then basically provide equivalent credentials or in the same format to workloads of all stripes based on policy, right? So the policy may be this workload will only run under confidential environments, but that will not be decided by the relying party. To your other thing, AMD already does it. Well, we can't have something that's AMD specific or ARM specific or Intel specific, right? So we, if one works better than the other, it will probably get greater adoption. And another thing in response to what you said is if my workload runs confidentially and is issued a, say, X509 certificate to that effect, and then there is 100 workloads that connect to it and need to effectively ensure that they're going to the right place, and that policy changes on what constitutes trustworthy. You cannot change 100 clients that may be distributed, that may be God knows what, every time you went and updated firmware on your AMD CPU or Intel CPU or ARM. Like, this is agnostic of that. So what you need is you need to have a policy decision around how you issue a credential to a workload that's separate from the point where this is evaluated. So where it's evaluated, it's business centric. It's hardware neutral. It is firmware version neutral, right? So that what needs to happen for this technology to take off, in my opinion.
Yeah, if you don't mind, I'd like to follow up on that. I think leaving aside proprietary mechanisms that already solve this problem, which I understand, what I think can be worse is having a third party acting as the credential issuer, because the credential has been issued in response to an attestation, which is one time obtained at some point in time. But the workload may present that credential over and over again, even though the security state in which it's running has changed. And I mentioned the live migration case as being an example.
We're almost out of time, unfortunately.
Yeah.
Yes.
Yeah. Okay.
So we'll let Hank go, and Usama has said he will take his questions to the list. His primary concern is on terminology, I believe, and that'll take a while to resolve. So acknowledged.
Hank.
All right, Hank.
So yes, hi, this is Hank. First of all, wanted to reply to Giri. Maybe it's useful to look at the AMD practical implemented solution and see what we can learn and abstract from that into the models Mark was highlighting. So I'm not entirely sure about that. My actually question was, the claims mapper seems to be like an appraisal procedure that could be part of the verifier. I'm not entirely sure about that, but it looked a little bit like that.
It could very well be, right? So if your attestation results convey the industry standard credential to your workload, that's awesome. But if
yeah, exactly, something
right,
to
and you're working
extent,
with the existing Microsoft Attestation Service or Google Verifier, and you get back whatever it is that they give you, that's not what your relying party can expect, and this is why you will need an additional mapping into this business-centric thing. So I'm basically saying I'm trying to cover all bases here.
Yeah, okay,
All right,
but that could be
you.
part of the standards process. Okay, thanks.
We're going to go to the next draft. All right, so this is Michael Richardson, and we are a little short on time because of running over. Yep, it's right here. And Michael's going to use the clicker, Ned.
Yeah.
Oh,
yeah,
perfect.
he did it.
It's
Yeah.
all set up.
Yeah, he has it set up. Okay, so this is some work that come together with a few different documents. Ramki Krishnan and I mostly have been doing this. There's Diego and a couple other people have been involved in this. That work. There we go. Is that the second slide? Oh yeah, okay. So there's 4 documents that are around. One is from me, geographic results. Another one is from me, which we talked about at 123, which was proof of position. Someone has suggested I try to add another O to that. But 8-year-old me hasn't come to do that yet. We have some geofencing work that's around that Ramki and some other people have proposed both here and at Whimsy. And then there is some other work doing basically using time, speed of light limits how far you can go. So if you get a response within some amount of time, then you can know that something must be at least this close. Otherwise, you have managed to violate the speed of light. So, okay, that's all wonderful. So we can do all these things and we get a single result. And so the first document I produced was basically, okay, so we have many different ways of getting there, some of which you may find trustworthy and some of which you may find not trustworthy. You probably maybe don't think GPS is trustworthy until you do. And then you can get information from LTE towers and you can have an auditor, is my proposal, to go do it. But at the end of the day, you want a result. So part of the question of this thing is, how should we organize this? Because we think that we want a verifier to produce a single geographic result, which is essentially the relying party doesn't need to know how it was produced as long as they get the information they need. Okay. Now, obviously, if it does it you shouldn't trust a verifier that uses a method you don't trust, but having decided that you're going to trust methods 1, 2, and 4, then you get the same answer. So how would you like to do this? Would you like to put it, as one document with many different pieces? There's a lot of different ways we can do this. For instance, we could have geographic result as a document in here. And it's a fairly simple document, by the way. Go read it. Basically, it gives you a bunch of different options as an EAR subclaim. A lot of it is jurisdiction, right? You don't really care, is the example that Mark and other people is, the workload is in Germany, right? That's important from a jurisdiction point of view, but actually it might be in the German consulate in Montreal, and that may count as jurisdiction Germany. Okay. Or it might be Kaliningrad, which is an exclave of Russia. So you actually have to know something, and the verifier has to do this. If it's going to do with GPS coordinates, it has to know how to deal with all those things, but there are other ways of doing this. And it turns out there are in fact exclaves inside exclaves, and we decided not to do with that because there's like 2 of them in the world there. So this is one way to do it. We could have a single results document. We could have some appendixes that say, here are some ways of getting there. We could have the other way, which was this way. We could have a bunch of documents that say, here are some ways of getting some results, and here they all feed into a document that does the result there. And there are other possible ways of slicing and dicing. So before I even think of asking you for an adoption call, the question would be, well, what shape should this take? How would this working group like to work with other working groups, including WMSI, but I don't know. I mean, the NTP people, there was some back and forth, but I don't know whether we need to involve them or not. They have some protocols that are useful. So there's some, there's some other results out there. There is a claim in 8176. There's some other work in other places about what's going on. And we can incorporate that or not as we go forward. What are some of the use cases? Well, this is a really busy slide. You're not expected to understand it all, but there are some processes here involving an AI agent and a workload and some other things like this going around. And we wrote the slide from one that had indecipherable fonts in it for there. There are other test cases, there are other use cases where it's important to know that something that reviewed a contract did it with the right jurisdiction in mind and was running in the right place. And this diagram, as you can see, comes out of some Microsoft AI agent thing as well. It's a completely different kind of geofencing than other things. I'm not actually sure. I'm not actually personally convinced that this exactly fits into it, but there's people that seem to think that they need this for this. We have the Nazar situation, which we had a BOF in March, which is not dead. There's still people that want to do this, but it'll be done in some other way. Again, geographic results, I think, will be mostly created by auditors, not by GPS. So it's again, how much do we want to put together? How much commonality do we want? Each one of these things could have their own results claim, completely separate from anyone else's results claim. I think that would be a waste of time. On the other hand, we can make results claims that are so complicated to deal with everybody's particular, corner case, that it's so complicated that no one wants to use it. They're just like, yeah, just give me one string, I'll deal with that. Okay, and that's about it. So, discussion. That's what I'm interested in, is mic time. How would you like to organize this? Do you understand the problem, I guess, is part of the question.
Sama, you Dresden. I think that would have been my question. What is the problem exactly that you are trying to solve? If I understood correctly, from my understanding, you are basically saying that there is an attester somewhere, and there is a verifier, and you are trying to provide to the relying party where that attester geographically lies.
Yep.
And you are getting
not necessarily by coordinates, but perhaps by jurisdiction. You are in Montreal, it's more important than you are at coordinates XY.
Sure,
right.
That I understand from GDPR perspective. For example, it's in the EU, data is attested is within the EU, but not, let's say, outside of the EU. That makes perfect sense.
Right. Yeah.
But what doesn't make sense to me for now from your presentation is, how is the verifier going to judge that? It has to somehow come from the attester that it's lying in a specific location. And How is that location provided to?
So there are three ways that we know of right now that we think that would be useful, and they're useful for
Okay.
different environments and different people with different amounts of different risk of use.
Yeah.
Okay, so the idea here is that we're going to get a common result from the verifier. So the format of the verifier is commonality. So that means relying parties don't have to go into the details of exactly how did all of this happen. They need to trust that it happened, but they don't need to know the specific maps or details. That's the verifier's problem to do that. How is that going to happen?
Yeah.
So there are different mechanisms. Okay, so one mechanism is actually it's not a verifier at all. It's an endorsement. Someone walks up to the equipment, says, I see you there. This projector is right here. I'm going to somehow attach a tag, an endorsement to it that says it is in the Agora room, and done. That's an endorsement. I can put it in the device signed by the endorsing agency, or I can put it back through the verifier through CORIM or something of endorsement. So that's actually not evidence at all. It's actually an endorsement completely. So the verifier simply translates that information to whatever makes sense, right? It may literally be just a one-to-one kind of thing. The other scenario on the other side, you can ask for, if you somehow trust GPS or LTE towers to give you correct information, you could do that. And the verifier, maybe the 3G company doesn't want to tell you everything about their towers, but is willing to run a verifier that would tell you based upon a tower ID where that tower is, or maybe just what jurisdiction it's in. So that would be useful, and you wouldn't have to know that, but you would have to obviously trust that that happened. Personally, I'm skeptical that any sane person in a data center with confidential workloads is not going to wrap their thing in a Faraday cage and therefore be completely unable to get any signals in or out, which is what I would do. So that's not going to work, even if you did trust the GPS somehow. So one answer is someone walks up to a box and says, I know where this box is. I put an endorsement on it. And then all the other boxes say, hey, I'm less than a nanosecond from it. I did do the math, it's 4 meters. I must be within 4 meters of that box if I can get a packet to it within a nanosecond and back. Otherwise, Nobel Prize, please, I violated the laws of physics, right? So you obviously can't know that the box could be closer than that, but you know it can't be further than that. So that's an example you would use physics. And there are people out there, and there are some other drafts that are doing this in a couple different places, saying, okay, that's another way of doing it. So there's a lot of different ways, and we could come up with new ways of providing evidence of location. But as we did, the verifier would say, I don't need to do all those details. I don't care which cabinet you're in. I don't care what your city in. What I care is that the applicable laws that apply to you are country X. That may be all that matters. So, Mark, so there's a bunch of questions on the queue here. I haven't got to them.
Well, mine's going to be super short. Important problem. And I believe it is a special case of composite attestation. As in, we need to know things about the workload, and we need to know things about the hardware that's hosting it. Location is certainly one of them, an important one. I just wouldn't want to treat it any differently than any other claim that you have about the hardware. That's it.
I'm not saying it is any particularly different than any other claim. What I'm saying is just we're going to make this results, and there are many ways of getting there. How would you like to organize the documentation for all of this? Because we can repeat things, right? We can, that's really the question. How do you want to organize the work? Work seems to me very obvious, and I don't think that it's necessarily very controversial, but
there's very little location specific.
Yeah.
That's all I'm saying.
Yeah. Diego, you were in the queue?
And we have 3 minutes.
Going to be very fast, I promise. Diego here. Basically, thinking about the documents, etc. I believe that what is important is what we separate how we make how we build the evidence and how we exchange it with verifiers, etc. That is 100% rats, I would say. And then it's about the different methods, because I was yesterday talking with Karen about PTP and how the proximity is calculated and things like that. Probably that belongs elsewhere though we should be referencing them. So that's
Right,
that's
right.
my take.
And that's what I think is probably the right answer, is that we should publish an RFC on the results part of things. One of the questions is, you could suck that into EAR if you wanted to, if the timing was right. It's a fairly,
Yep.
2-page thing, or it can be a completely separate document. And then other mechanisms, as people invent them, can say, and the verifier will produce it
Correct.
according to this thing.
Exactly. Karen was even thinking about bringing this PTP to IEEE because they are working there on some aspects that are apparently connected. For
yeah,
example.
Yeah, and I actually don't think for the speed of light thing, you actually need accurate time. What you need is the time stamping hardware that gives you accurate time so that you can measure the back and forth at the lowest level. Hank.
Yeah, hi, this is Hank. I made notes. So yeah, first of all, I'm basically mostly interested in the attestation result stuff. And yes, it could be EAR stuff, but we can have it separate right now. First thing I'm really interested in is the claim about the timestamp, recentness, freshness, or epoch ID. So that is, how long is this statement actually valid? Because you can move things sometimes if you're a car, it doesn't work that well. Then I would like to have the source of claim processed by the attester. How did the attester actually get that?
So you want within the result, you actually want a statement as to what the process was. So we need a IANA registry of mechanisms.
For example, then method of registry of location method.
Yep.
This is my third point. And then how do we deal with distributed systems that are across multiple geolocations but doing one thing? So that is something we have. This is more complex, maybe.
Location Earth, done. No, okay. Yeah.
So Ned, make your comment.
My comment was how much of this relates to 9334 in terms of like appraisal policy for attestation results, which is currently out of scope. Is that what we're thinking?
No, I don't think that's really fitting into it at all, but I'll think about what you just said.
Okay.
So my comment without a hat is that I'm Deb Cooley, not your sec AD at the moment. I think you're going to need to be extremely careful about your privacy considerations
Absolutely.
on this sort of thing.
Yep.
Right. So whether it's intended to be used that way, the question is, can it be abused that way?
Right. Right. So for instance, I mean, I think that a lot of things are going to return country code jurisdiction foo, done. That's it. And all the other information is, well, that's not a zero size thing either. You could be at both sides of that place, right? But also I think that put in the results so you can tell me it's useless. I wrote, rack unit 12, cabinet 9, room 12 of data center 9, right? That may actually be what you want to know, right? For something. Okay. All right. Thank you very much. I appreciate your time.
Okay, next speaker, looks like it's Usama. Ned is getting your slides up. And we're tight on time.
Right, so we had a lot of non-technical discussion yesterday, so today I want to talk more technically about it, and I will take the questions at the end. Please don't interrupt in between. I want to go through the material. We have to, wherever it lands, my question or my comment is, we still need to fix all the things that are problematic. Every working group last
I am
call.
going to interrupt. You have still the in working group last call circled. Those are not really working group last call.
Yeah, I'm not going to talk about that. I'm talking.
Okay.
I'm going to talk about this today. So, okay, so we can talk about other things in the list. So what I want to focus on this slot that I have is the threat modeling, which was my main goal. And more technically, please. So the question I asked yesterday was, what else would the working group find useful? I didn't get any answer whatsoever to that. There were so many other discussions. But what I really want to point out is that there are four main things that I'm concerned about: threat source, capabilities, threat action, and threat impact that I want to see in the RETS considerations. And here I have an example, 3 examples specifically. Replay attack, we always talk about it. RFC 9334 has a detailed section on this, but there are still some things which are very specific and need some nitty-gritty details, which are, so to say, It can be across multiple connections as well as within a single connection. And the first one I'm going to talk about is multiple connections, which is to say I have a verifying relying party, which is a combination of the verifier and the relying party on the left, and the malicious attester on the right. Malicious attester at this point in time is in expected state. The verifying relying party sends over an attestation request, which is shown as attestation request 1, and the malicious attester generates an evidence, which is, since it's in the expected state, it's a valid and genuine evidence.
Can you
Yes.
just ever so slightly, maybe a centimeter, move back away from the mic? The remote
Okay.
people are having trouble hearing you. You sound
Okay.
fine in the room, I think.
Okay. Is that better? Okay, I just had a meeting with Ecker, so I'm maybe faster. Okay, so is this better, remote?
Yes, thank you.
Okay, so the evidence that will be sent over to the verifying relying party will be the evidence 1 with expected state as it was in expected state. Now, something has changed, not necessarily compromised, but something has changed. For example, a GPU was connected to the CPU, and that GPU has been now disconnected, which means that now it is no longer in a state that the verifying relying party was expecting. And that would basically mean that now it's no longer in connection with that, no longer in the expected state that the verifying relying party was expecting. So what will happen is, for the first interaction, the verifying relying party is going to accept that evidence. And in the second, after some time has passed, now the state has changed, some GPU as an example I gave, or the other way around, a new GPU has been attached to it. So the state has again been changed, or even worse, like for example, the state of the same GPU has been changed. It has transformed from a trustworthy state to a non-trustworthy state. In that case also, it can still replay the old evidence that it generated if we have no freshness criteria, which is to say that that is the red arrow which is saying replay evidence 1 with the expected state that it had from before, and that will be actually giving it the state that we did not expect. But the verifying relying party in that second connection, which is shown on the extreme left, it will still accept that if it has no freshness criteria. So that's one important security consideration. And second, on this slide, what I'm going to show is the same, within the same connection, it has now 2 different remote attestation interactions, with which it's checking that the same scenario happens, but it's within the same connection, which is to say, kind of consider the case for RFC 9261 exploited authenticators, for instance. It's running on the same connection. 1 day has passed or some time has passed, and now it wants a new status of the verifying relying party, of the status of the attester. And the same things have happened as I just described, like the workload has changed, the GPU connected has changed, or the platform itself has changed, something has, firmware status has changed, and so on. And then we want the status still to be reflected as the expected state, but if there is no freshness criteria, it can still replay the old state. That is in the second remote attestation interaction. And the verifying relying party, if it has no freshness check, it will still accept that, which is the problem. So very confusing. So replay kind of people know about this, but relay attack is well less known or well less understood, so to say, which is exactly this one, that an adversary forwards the attestation nonce over to a genuine attester, gets back a genuine evidence, and then pretends that it is its own evidence. So to say that that's shown as the relay evidence with which it can convince the verifying relying party that it is actually it is actually pretending or impersonating that genuine attester. So the verifying relying party actually believes that it is talking to the genuine attester, but the connection is actually established with the attested with the adversary, actually, which is shown at the red cylinder at the bottom. So the privacy considerations here are that the claims are visible to passive adversaries, of course, because remote attestation does not protect that. There is no encryption to protect these claims. There is only a signature over those, and that's the privacy problem, that the claims could contain the hardware level information. And security problem is this relay attacks are possible, as I have described. So replay, relay, and the third one, which is even wellness known, and that's what we considered in the identity crisis. And June asked about the definition. So specifically, I have a definition here on the list. He asked for specifically this, which is to say that a network adversary would deliver your capabilities and access, for example, via foreshadow attack, or it can be some other attacks, because none of the trusted execution environments actually protect you against these hardware attacks. To attestation key of any machine in the world, that's the keyword, that it's not specifically the machine that we intend to talk to. It can be any other machine, because it's in the, as long as it is trusted by the verifying line party, that will do the job. And what is the threat action? That is, can redirect a connection intended for a specific infrastructure provider to the compromised machine, potentially resulting in the exposure of confidential data. That is the impact. So the four things that I talked about in the previous slide are threat source. What's the threat source? That's a network adversary versus the endpoint adversary, which still for remote attestation is in scope. Capabilities are two. Number one, the Olivia attacker to do that redirection to some other machine. And number two, that it has the private attestation key part of any machine. Third, threat action, that is, it can redirect a connection. And finally, the impact is that the confidential data that it was supposed to protect is no longer protected. It can, or potentially it can be accessed. Okay, with that, I have the mitigations here, which I would like to see. For instance, as I said, this is just exemplary. There are so many attacks otherwise which the draft will add, or wherever wiki or whatever, wherever it lands, that's a separate thing. So as to say that I would like to have all these kind of attacks kind of agree on that as a working group, that these are the kind of attacks we are concerned with in the remote attestation part, and how we can mitigate those. Examples of that are, for the first one, the replay attack, that we need some freshness criteria, which is to say, like one of those attestation nonce, timestamps, if the time is synchronized between the two parties. And the third one, epoch handle, epoch ID, epoch markers. I sent it out on the list. I have a link at the bottom, which is to say that I'm not sure what exactly do these terms mean. So that would be one of the outcomes of this whole effort. And I will come back to this point, but I do see value in this, not to say that this is going to be much more effort. So we can actually agree on some of the definitions which other drafts can then use. And for example, I have one part of that email, which is to say RFC 9783 says 3 times epoch handle, and it references section 10.2 and 10.3 of RFC 9334, whereas RFC 9334 never talks about epoch handle at all. Second example I have is it also talks about epoch ID, and the confusion in my mind is, for example, that what exactly is that epoch ID? It's not defined within this draft. It's not, no reference is given to it, no explanation is given to it. I don't want to see two terms being used for the same thing, or different terms being used for a thing that we want to talk about in the same sense. And then for the relay attack that I talked about in the second one, which was a binding to the specific connection, be it, let's say, TLS or ad hoc or whatever that connection is, or whatever that thing that connection is built from, that secure channel, there should be some connection to that some kind of binding of that evidence to that. It can be achieved by various ways. So some of the mitigations that I will add here will be like to provide that kind of connection to the secure channel, so that the evidence that this relying party had, just as a recap, that this evidence which is shown as the relay evidence, even if it is relayed, the verifying relying party will say, this is not the evidence that I was expecting for this specific connection, and it is coming from somewhere else that I do not trust, some other connection. And that is the advantage of having a connection to that specific channel, in which the verifying relying party will immediately actually reject that connection, reject that evidence by saying that the connection I was running with the with that specific entity is not the one that I expected this evidence to be. Okay, going back to the mitigations, the third one I talked about the diversion attack, And here the mitigation is that one has to have a connection or a binding of the evidence to the infrastructure provider. And for the diversion attack that I defined in one of the slides, and one specific way in which I can avoid that is to say, for example, in the WhatsApp case, that I am talking to a machine which is owned by Meta, or it is placed in a Meta data center rather than some other data center. And Hank, I will come back to questions at the end. Let me first finish. Sure. The specifications to be improved. I'm here specifically now talking about something other than the threat model, which is to say that RFC 9334, for instance, talks about unprotected evidence, and it says a conveyance protocol that provides authentication and integrity protection can be used to convey evidence that is otherwise unprotected, for example, not signed. And I would argue here that if evidence is not signed, that's completely useless because it's not providing you any guarantee at all. It's no use of compared to having a simple TLS or whatever that session is built on. The example I give here is TLS 1.3 in the draft, which is to say that the guarantee I will have with the evidence which is unsigned will exactly be the same as the one I will have with simple TLS 1.3 without having any evidence at all. It just doesn't simply add anything on top of that. Most important thing is to have an evidence that is bound to the trust anchor, which in this case specifically can be the hardware manufacturer, for instance. And that is only possible if we have a signature chain that is going back to the root of trust. Otherwise, that's completely useless. Second thing that can be improved, specifically RFC 9334. Yesterday we had discussion. Let's start with the RFCs rather than the drafts which are there. I think this links back to what Mark was saying, which is to say on the right top you see an entity called identity supplier, which is very important because I would like to recognize that which attester is it that I'm talking to, or which specific attester are we connecting to, which is really important because I could have replicas of the same attester which are really genuine and can mess up with the consensus protocol. For example, the example that I would give here, for example, would be, let's say I'm doing a BOF. I would like to have people contribute more to yes rather than no, and I would like to replicate more of the yes versus no. And what I could do is I could run that in the I could run multiple replicas of the people who are saying yes versus the no's, and then since they are the genuine replicas, all the SGX enclaves, and they are all saying yes, that will multiply my goal, and I can achieve more consensus, more than the reality that I would have. So they are all genuine attesters, all valid replicas, but we need to really identify which specific replica or which specific instance of that attester are we talking to, and that is the one which is given by the identity supplier that gives a specific identity or associates a specific identity to a specific attester. And another, so the identity supplier as a role is missing in the RFC 9334, and identity as a conceptual message is missing in RFC 9334. And as the example I gave for consensus, it's really, really important to have that identity. Attestation challenge is also one of the messages which is missing. So the three examples that I gave you, timestamps, nonce, epoch ID or epoch marker or whatever you call it. So all the three things, so these are exactly in line with what we think of as an abstract level as the conceptual messages, and I don't see why we should ignore them, not to consider them as conceptual messages. Happy to have a discussion. I think I'm almost done, which is the final slide is RATS documents are very much focusing on the very first which is shown here, and as Nick and Chris argue, your specifications are not meant to be just read by the implementers. They are also meant to be equally read by the researchers as well as the protocol designers. I think this is really something that we really have to understand and agree on, because this is a real problem that I'm facing, that I as a researcher, I as a protocol designer, for example, I'm using RATS work in the SEAT working group. I need to really know what is the security consideration that I buy from a specific draft or a specific, let's say, design or whatever that internet draft is doing, a specific format or protocol or whatever it is. I need to know as a researcher and a protocol designer that what exactly is the specification, or what exactly is that security consideration that it is giving me, or what exactly is that privacy consideration I have that I'm getting from here. And that's pretty much it. I want to thank all the people who have contributed to it, in particular Ira who gave this idea, Simon first, and June also provided feedback on the list. Ivan added to the legal perspectives, and Thomas Fossati and Jonat with those, with the two, we have constructed all the figures that I have shown. Thanks very much. And Hank, please go ahead.
Yes, hi. So this is Hank. So first, my first comment is this slide deck is not suitable for ask questions later because there's a lot in here and you can't just do this all in the end.
Which slide are you talking about?
So first of all, I don't understand what the very left vertical on slide 4 was.
Slide
I think
4.
it's another requester. No, it's one.
Is this the slide you want?
No, well, maybe one before.
Is
Yeah,
this,
yeah. So the very left vertical, I don't know.
so
what
the
that
very
is.
left is the separate connection of the same verifying relying party. So
Okay, I see. So yeah, so and in general, I agree with all your mitigation methods. If you cannot bind your evidence to a conveyance channel, you always run into replay issues. That is a known problem, and I think freshness state helps here on the verifier side if you're talking to the same verifier. But if that is not the case, then the replay attack without channel binding is just nonsense. It will just always be happening. You can take authentic evidence and just replay it. That's a channel binding problem. I think that's well known.
So
Then-
Kathleen with the chair hat on.
Yeah.
Please handle these in issues,
Sure.
and then we'll address them in the right place, whether
Yeah,
that
make
be in
ton of issues.
an updates document or in that wiki for the future drafts.
but my question is issues to what? That's already an RFC.
Each-
Issues where should I file the issues? That's an RFC.
Can I finish, Hank?
Sure.
Thank you. So for each of the problems you raised,
Mhm.
do it as an issue tracking so that you can get consensus on each item.
But issue tracker on which GitHub repo?
Right. All right. I'll explain later. Apparently,
Okay, sure,
nobody's
sure.
getting what I'm saying.
Okay.
We'll try. I think it's easier to track each of these to get consensus
Sure.
individually, right? So each of the problems you raised,
Mhm.
we'll
Right.
come up with a mechanism to do that.
Sure.
Okay,
Thank-
may I continue? So if you are able to create not correct, so unbelievable evidence is false, I think your TCB is broken, or even worse, your root of trust is broken.
Which
You know,
which specific slide are you talking about now?
at some point you generate evidence that is a lie. If that is possible, your TCB is broken. You have a greater problem, you have a fundamental problem.
I'm not understanding which slide do you
Earlier.
want me to
I
do?
don't know either because it was so much. It's before 7.
Is this seven?
Yeah, yeah. This is before it's, yeah, I think.
Replay or relay or
Yeah,
divergent?
yeah. And in this slide here, the tester lies in the second reply.
Okay, second
Yeah, because the
remote addition.
TCP change is compromised.
Yeah.
If you now can produce authentic evidence, your TCP is broken.
No, you're not producing a new evidence. You are just replaying the older evidence that you previously had
Yeah,
produced.
then it's the same as before because you need conveyance of state. Okay, we can move on. Same answer than before. Then on slide 7, of course, if your AK is leaked, the whole system is broken. That is a fundamental issue with the whole.
Right. So just to clarify, I'm not saying that the AK of the attester that you are talking to is compromised. I'm saying anywhere in the world there is one machine for whose attestation key is
So this
compromised.
is not true for TPMs, for example. Then maybe we should all use PPMs if that is a problem. I don't have a lot of time, so I'm moving
Okay,
really
so can we
fast
move
here.
to the other one? So you
it-
can you send your comments on the list?
Sure.
2
But I
minutes,
wanted to
2
our
people in
comment.
the queue.
So
Sorry.
can we move to the other people, Hank? So I want to give them the opportunity to speak. You can send on the list.
Okay, well, one other thing. Unprotected evidence, look at RFC 9781.
Unprotected evidence. I disagree with that.
Okay, I have leave some comments in the chat. So the first for me is that
Which slide do you want me to be?
I just talk to save time. I say that for the replay attack, for me, it's the time to check, time of use problem.
Speak closer to the.
For me, that the replay attack in your scenario for me is the time of the talk to attack, time of check and time of use.
Time of check to time of use is a different attack. Replay, I'm saying that it's the state of the attester which is change, which has changed. Time of check to time of use is a separate attack. I can take it on the list. Any other comment?
And that when you say that you need to bind the evidence with the connection, so you need to be careful about the privacy, because in that case, others can
Sure,
trace.
yeah. Yeah.
And for the UCCS things, I think that one thing you need to consider about the cost. You can have the put the security at very high level, but you cannot make it run. But
Sure,
for the case of the UCCS, it is for IoT. They cannot doing the crypto things. So you need to protect them by some kind. So there's certain methods you need to propose.
Right. Okay.
Yeah.
So we will take this on the list, but I'm not agreeing to you,
And
because
so, yeah.
if you want to protect that, then just don't use attestation at all.
But they have the different levels of protection. So that
Sure, we will take it on the list.
And for the when say that we need to bind attestation readout to specific attester, I think that's in some protocols like the RADS with OAuth is already addressed such issues. So these can be achieved by the combining rights with other protocols.
Okay, so June, may I give the opportunity to the last? So can you take it on the list, the remaining comments? There is someone else on the queue.
Just let him say his comment.
Okay, sure.
People can
so
leave the
I will
room
leave
if the
for
session is
other people.
officially
Okay.
over, but if you want to just say your comment,
Okay, you can say.
it quick. And then we'll let Dave. Dave, I think it's your turn.
Yeah, Dave.
Jean sat down.
All right, thanks for this presentation. I agree with slide 7. This is a good slide. So thank you for this presentation and this discussion here. At the bottom of slide 5, you have the channel establishment there, the attested channel there. If you go back one slide, this one doesn't have it. And if you did, it'd be at the bottom there. I just wanted to point out that the same problem happens as this one is talking about this replay. The same problem happens if the TCP on slide 4, right? The same problem on slide 4, right, happens if the TCP change and compromise happens after the channel establishment. It's still the same thing, which is the end state is you have an attested session with it to a compromised device. And so this is what 9334 in the appendix, it calls the threshold in the computations, which is what's the delay that the relying party is willing to accept from when the attestation happened. And it's for exactly this problem. And so my point is just in the discussion of this replay attack here, I don't see it as significantly different in a security perspective to where those two things happen in their order. The end state is still the same in both cases. And I think we should take that into account. But the point is that 954 does talk about this, and that's what it uses the threshold for. It says you've got to have some policy for how out of date your attestation is, even after the channel is established. But there's always this race condition that's there. It's just how much you're willing to accept. And so at least we do talk about that. But I thought this was a good diagram. But I think if you add that contribution into it that says this could happen before or after, and it's still the same issue of having an attested session of a compromised device. And so that's my only suggestion to you. Otherwise, I liked all the rest of your stuff. Thank you very much.
Yeah, thanks, Dave. I think I completely agree with you. All the things that you said. Thanks very much. Okay, thank you all.
Thank you all, and we'll see you on the list, and we'll figure out a way that each of these items that Usama is working to address can be tracked so that we reach consensus to put them in the right places. And we'll, go ahead. Oh,
I was going to say, I just want to thank the notes takers and all those who participated.
And I think we do need more interims. So I think Ned and I need to collaborate and make sure that happens at a higher cadence, because clearly there's a lot to discuss. We don't have enough time at the mics. So if we have more focused time, something like when these security considerations get further developed, there could be an entire interim just on that. So we can really hash through and get to agreement on different topics. So thank you all. Appreciate your work and focus on this. Thanks, Ned.
I'm just wondering about, for example,
No, hombre.